One of the most misunderstood and misapplied ideas in math is proportional reasoning. That's your ratios, your rates, scale, unit conversions. They are everywhere in real life, from recipes and maps to speed and population density. But most students learn to plug into a proportion formula without ever understanding what the numbers actually mean. And when AI comes into the picture, things can go either way. Students can use it to skip the thinking altogether, or they can use it to reveal their thinking. And in this episode, we are going to show you how to design assignments that use AI to strengthen proportional reasoning while making it hard to cheat, because the work is rooted in context, reflection, and explanation. So let's get into it. Step 1. Ground proportional reasoning in real-world experiences. Don't start with x over y equals a over b. Start with something they've lived. You can prompt your students to go to their AI of choice and ask it to give it some real-life examples of ratios and proportions as a teenager might use. Then they can choose one and write a story about it. They can explain the quantities being compared, create a visual like a bar model, a double line graph, or a table. Now, they're not just solving, they're exploring their relationships. Step 2 is that you can have students use AI to generate incomplete problems. You can have them prompt AI to create a proportional reasoning problem, but leave out one number and ask it to find it. Students now are filling in missing values, justifying they know it's proportional, and describing what would happen if the relationship weren't proportional. This teaches them to analyze structure, not just solve equations. Step 3. Challenge students to critique AI-created solutions. You can have students prompt their AI with, explain how to solve this. 3 pencils cost $1.50. How much would 7 cost? Then ask students to identify if the solution was clear. What assumptions did they make? Could it be explained in another way? They now become mathematical critics, which is a crucial skill in the AI era. Step 4 is to teach multiple representations and have them have AI show all the representations. Students can use a prompt like this. Show a table, a double number line, and a graph for the relationship of 2 gallons equals $6. Then you can ask students to describe the constant of proportionality. Have them generate a story that fits all 3 representations. They can reflect on which one helped them understand the situation best. This builds flexibility and not just formula use. Step 5. Encourage students to co-write proportional scenarios with AI. So for example, they can write a situation involving 2 kids who are biking at different speeds. Include enough information to compare rates and figure out when one catches up. Then identify the quantities being compared. Solve the problem using a strategy of choice. Extend the story and predict what happens next. Now they're authors, not just answer getters. Step 6 is to use AI to vary the structure of proportional reasoning. Prompt AI with this. Give me a problem that looks proportional but actually isn't. Have students solve it, justify why it's not proportional, write a corrected version, or flip it by asking AI to give a problem that doesn't look proportional but actually is. These contrasts build mathematical judgment. Is to design tasks where students must create and evaluate AI outputs. Sample progression can involve prompting AI to explain how to solve a proportions problem, compare it with their own explanation, find a different method, rank all 3 methods by clarity and usefulness, and then write a recommendation for which method to teach to a younger student. This kind of thinking isn't easy to fake or outsource. Step 8 is to build proportional reasoning portfolios. You will ask students to collect 3 AI-generated word problems, their own visual models, a written explanation of the constant of proportionality, and 1 reflection on how they misunderstood a proportion and later corrected it. This creates evidence of growth and not just correct answers. Step 9 is scoring and rubrics. We want to use rubrics that reward reasoning and communication. So for example, you can have 30% go to the explanation of proportional relationship, 25% go to visual or tabular representation, 20% will go to comparison of methods or strategies, 15% will go to an AI critique and a reflection, and 10% can go to real-world application or extension. When students know that the rubric values thinking, they stop trying to game the system. And step 10 is to anchor tasks in student voice and decision making. So here's a strong assignment that you can give to your students. You tell them you're planning a school trip and they need to use AI to model costs for different numbers of students. They can calculate per person costs, transportation, food, and time. Explain your reasoning and design 2 visual aids. Or you can have them create a social media infographic that compares 2 prices using unit rates. They will use AI to help with visuals, but you must check, explain, and justify all claims. Now, students are solving messy, meaningful problems using AI support, but their judgment is the driver. So, proportional reasoning isn't about cross multiplying. It is about understanding how quantities grow together, relate, and scale. AI can solve proportions instantly, but AI cannot decide if the quantities make sense in a real world context. AI can't reflect on whether a solution fits a scenario. AI can't teach students what it feels like to think proportionally. Only students can do that. And only educators can design the space where that thinking happens. When we use AI as a co-thinker and not a shortcut, we are preparing students for math and for life. And when proportional reasoning makes sense, students stop asking, "What do I do?" and start asking, "What's the relationship?" That is the shift, that is the power, and that's how we keep math and learning human.